Hello, in this video I'm going to talk about how to learn about doing reverse engineering in video games, to understand how do they work, how can you modify them, maybe by making changes in memory at runtime or just modifying directly the game files, and more specifically about video games that can be emulated on MESEN, which is an emulator that can run games from Super Nintendo, Sega, and other platforms. And the benefit of this emulator is that it has a lot of debugging utilities to inspect the memory, look at the sprites, step-by-step debugger. And the main benefit that this emulator has over others, not all of them, but the main reason of why I like this simulator is that here on the right you can see that you can write some Lua code to program some actions that will be reflected into the game that is being emulated. Like for example, you can write some Lua code that when some key in your keyboard is pressed, it runs some memory inspection, it can write some memory. So for example, I had some Lua code that after I learn which address in the memory is stored the life of a character, then I can just write some Lua code that when I press certain key, it will fill my health to 100%. And you can also do this manually, like once you know the address, you can just go to the memory inspector and change the values directly there. But this is how you will do things before. You will just play with a lot of, like if you want to understand, for example, like here we have a lot of stats about this user in a Super Nintendo game called Inindo, Way of the Ninja. Good game, by the way. Let's say we want to know when the level is stored on the memory, how much experience is needed until the next level, health, energy, values. The other way to do some reverse engineering here is that you will go to the memory inspector and look like, for example, health. Like how many memory values have the number 31? And then you'll go into a battle, get damage. Let's say the new value is 27. So now you have, give me the list of all the memory values that had before had the number 31 and now it has the number 27 and so forth until you find a single space or maybe just a couple of ones, and then you modify these values and you see that they get reflected into the game. So with this you can have a bunch of memory addresses and start changing these values and understand who's writing these values, who's reading from these memory addresses, so you understand much more the game. So this was the old way of doing things. So LLMs, I'm just going to say Claude code, but it could be any other coding LLM. Really good for learning reverse engineering because you can send the game files to the LLM and it can understand. It understands. I'm assuming you're a beginner like me. Like you understand much better than us the architecture, the concept values about the CPU, memory, RAM, and even how the binary code is stored into these game files. So you, without any integration, you can use LLMs to say like, hey, like I'm using MESEN emulator and I want to understand where the energy points are stored in this video game, and you give maybe the game files to the emulator, or you can say like, hey, like I'm in this playing right now, and the LLM will tell you some steps like, hey, okay, you're using MESEN emulator, so you can open the memory inspector, search for the values that are 12. Now use your energy, search for the new values, click here, 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 and there. And this is already like a good improvement, because it's like a teacher that's available all the time that you can ask any kind of questions on how to understand better these video games, how to understand the CPU, the memory, the binary code, like the assembly code that is running in this file. But it's still a slow process. Like if you have to do things manually, it's still a bit slow, because you have to click in a lot of debugging tools into the emulator. So the next step of working with an LLM is like, hey, like MESEN has this script window where you can write some Lua code that has some APIs that can inspect read memory, write into memory, write some callbacks that will run when some certain memory values get written or read. And the LLM can tell you, okay, run this Lua code in this script, and you will run it and let me know what are the values. So it's still a bit manual, but we are starting to speed up the process. Like I'm familiar with Lua a little bit, and I did my own scripts, but I was a bit slow and I wasn't very familiar with the Lua API for this emulator. So at least for me it was a slow process. I was still able to do a few things, but it was some trial and error until I got familiar with the Lua API for this simulator. But the LLM can write good Lua scripts on the first or second try. So that was already a good next step for improvement. And the next level of improvement, when it's like I found it really gets much more benefits of these LLMs for reverse engineering, specifically with the simulator. It's like, okay, the LLM is asking me to do a lot of things for the LLM, but what if the LLM can directly communicate with the emulator, and like instead of telling me run this Lua code, run these memory values, tell me what do you look, instead of telling me those instructions to me, it can execute it directly into the emulator. And that's what I wrote, like a very small and simple MCP. For the ones that don't know, an MCP is how LLMs can connect with other systems. So in this case, this very simple MCP for LLMs, what it does is it can run arbitrary Lua code into MESEN, and the LLM will just learn about the Lua API for this emulator, and then it will just start sending messages to the emulator, as you can see here in the right. And I also told the LLM to also send some small English description of what message is sending to the MCP. So we can stop here and like start getting into what's happening here. In this case, this is a bit doctored, like because I already solved this and I just made it faster, so we don't have to debug the whole thing over again, which it can be sometimes slow. So here, like the Lua code here is listening from messages coming from the LLM. So the first message is like saying, okay, the LLM acknowledge what I told the LLM to do. So in this case, okay, go find the player's level in the RAM for Super Nintendo. Right now the level for this player is level 3, and I want to change it to level 99. So in an ideal scenario, the LLM will tell, okay, in a previous debugging session, I remember that this memory address is the one that stores the level. So I'm going to read, you told me the level is 3, So I'm going to read from this memory address to confirm this is the level that's happening, and I'm also going to take a screenshot here. It will the Lua API for this emulator also allows you to take screenshots, and LLMs nowadays can very easily read text from an image. So in the step 3 is like taking a screenshot and storing somewhere, and it's also confirming that the level is 3. So in the step number 5 is telling the emulator, okay, writing 99 in this memory address. And in the step 6 is like taking a new screenshot again. And finally it says like success. I confirm now the level for this player is 99. So I think this is a very optimistic scenario how debugging works, but for this case, the way how I work with the LLM is like saying like, hey, remember that in our previous debugging session we learned that the level of this player is stored in this memory address. Let's give it a try and try to change to 99 and verify it yourself. So I think this is a very important part of working with LLMs. If you can remove yourself from the verification process, if the LLM can verify themselves that the work they did was correct or not, then the solutions are much more powerful because it can iterate a lot of times until it gets it right, and then you just come and appear and like evaluate the solution to see if it's reasonable or not, or maybe the LLM went into the wrong direction. But that concept is very important. If you can teach the LLM and give it the tools so it can verify themselves while doing a lot of changes, which is why I wrote this simple MESEN MCP. And once you solve the problem, like let's say I ask the LLM to learn where the level, like where the memory address for the level is stored, and it does a bunch of things and finally comes with the answer. I usually tell it to save the lessons into some file so I can use that information into future debugging sessions. And something that I also find very useful is like once I succeeded in some goal on this, like modifying something in these video games, to me it just did a lot of magic, especially at the beginning. So I can say like, hey, like describe me what are all the steps you did. Like let's discard all the wrong investigations we did and like focusing only on the final answer. Tell me which steps you done to come up with this answer. And just that is like a really good way for learn. So you can also learn and also take better decisions once you do more complex projects. But also, if you don't understand one of those steps, you can ask the LLM to go even further to explain you even more detailed steps or teach you more about the architecture of, in this case, Super Nintendo. And you can go deeper and deeper until you finally understand what the steps the LLM did. And yeah, you will get better at reverse engineering and gradually move to more and more complex problems. And for example, in this repo, the goal that I had was that this game, I like it a lot. It's an RPG with a little bit of strategy of a ninja trying to get revenge on Nobunaga. But the problem is that because this game is a bit old, it's very grindy. you had to grind a lot to level up, and I don't have that kind of time again anymore as it used to be in the past. So I wanted to make it easier to level up. So I wanted to um, reduce the amount of experience you needed to get to the next level. So what I did is I connected my LLM to this MCP, to the emulator. So I told the LLM, I'm in a battle, I'm in level 2, and after I defeat this character, I will be on level 3 after winning 10 experience points. Add some with your Lua code, start to inspect the state of the game on the memory to find what's the function and the code that is in charge of increasing the level from level 2 to level 3 on my player. And I want you to find the data for how much more experience points do you need to get to the next level, because I want to modify those values in half so I can level up much faster. And it did a bunch of things. It asked me to finish the battle a bunch of times, and it finally found that there was a table with a lot of values from 2 to 50 something, all on its own. Like the LLM found this table on its own. I didn't know this, and to be honest, I didn't expect that table. I didn't know what to expect, to be honest. And anyway, the LLM found a table from level 2 to 55 or 50 something, and that's it. The solution was just to in memory to these values gets loaded into memory from the game files, and I just asked the LLM like, okay, modify those values and to 50%, and then I continue playing the game, and like I confirm that the game was much easier. Like I needed less experience to go to the next level. So because I wanted to not just change the values in memory, but I wanted to change the original game files, so it's much easier. I gave another task to the LLM. So like, okay, now we know about this experience table. Let's find where this data exists in the game files. Eventually found out, and I asked the LLM to write a patch so other users can use this patch to make their games easier, so I don't have to distribute the whole game, which is illegal. And yeah, well, every time I found good progress in debugging, I told the LLM like to write all these lessons in this file. This is the experience table, and this is this is something about the patch, and also I was trying to also modify something on the game, because I thought these values were going to overflow. Like once, let's say I make the game super easy and you reach level 100, I read somewhere that if the level goes into level 101, the game crashes. So I also did some investigations with the LLM to find if you can limit the level to 100 and to modify the binary code. And these are some assembly instructions about it. And for me, it was very good learning, because I never saw how patching is being done for game files. And it was very interesting. But later I found out that that crash on level 101 was in another platform. It was something that was fixed for the Super Nintendo version. But that's fine. Like I learned a lot about this process, and it's also a good lesson that you have to verify that you're solving the right problems. But anyway, I think once I got all this information, it's very easy to ask the LLM like, write a website that describes how can we make the game much easier. And because I don't know like what's the appetite for people to make this game much easier, I just add this slider to make it, to keep it without changes, or to change the experience level like super easy, or maybe 50% easy, and all the values in between. Like for example, super easy is that you just need one experience level to get one experience point to get to the next level. And here you can see the experience levels required for the next level and some extra information. And for me, this was super useful for. I like this subject of. As a beginner of reverse engineering, I knew a few concepts, very basic concepts, but with LLMs, I feel like I move faster, and I have a teacher that I can ask with a lot of detail to explain me again what are the steps that have been done. Like, so I feel now I'm more efficient. I have a good source of knowledge stored in the LLM, and hopefully I can tackle much more complex and interesting problems. So finally, I think a little bit about this MCP for MESEN. I saw other ones, other MESEN MCPs, but I saw that were still in progress, or that require a bit more, like a new binary on C++, compiled from C++. So I wrote a simple one that has a very limited API, which is basically just run arbitrary Lua code into the emulator, which I think is the more freedom you give to LLM, the better. And the way how you install it is you can read the instructions here, but is you clone this MESEN Lua Bridge MCP. You run npm install, like most, as far as I know, most MCPs nowadays are wrote in Node.js. So it's also npm utilities on your computer if you don't know them, if you don't have them. And then you need to load the bridge into MESEN. Which, what does that mean? It means you ask MESEN to start listening for the LLM. So how you do it, you open this script window, you increase the maximum execution time to 10 seconds in case you're doing some long actions. You allow IO and OS functions. This means you can read files in your disk. This is because the way how the LLM is going to talk to the emulator is that it's going to write messages as files in your disk, and the emulator is going to look for the presence of these messages, and once it completes, it just deletes the file, which is super simple but very reliable. I tried with network access, but you can only have one active connection, and well, at least in my experience, it was not very reliable. When you have multiple sessions, or like you try to restart a session, it will just not work. So just using files, text files into some directory was, in my opinion, much simpler and reliable. So you also need to open a file that's on the Git repo, which is called bridge.lua, if I remember correctly. Here I just copy pasted the contents and I run it, And here you can see like, hey, MESEN MCP, bridge register waiting from MCP server to claim. And then now you can tell the LLM to use this MCP to start to talk with the emulator. As you can see here, like you will start to see messages arriving here. You can start by saying like, take a screenshot and open the screenshot, or start read some random value. And here I think I have some list of things you can ask the LLM to do to make sure that you can talk and interact with the emulator. And you can ask the LLM, like, read the official documentation for the Lua API for this emulator, and you can ask the LLM to give you a summary so you understand what things are doing. But the one that is read the most is this one. It reads some memory address from somewhere. Yeah, with this line, you can also install the MCP in Claude code, but you can use it in other LLMs that use MCP clients. And yeah, I think that's it. I wanted to share something about this MESEN MCP that allows you to execute arbitrary Lua into this emulator. I wanted to give you one example of a simplified example on how I use this MCP to achieve something I wanted to do with this game for a long time ago. To make it easier, some extra examples of how to make your findings much more available in a friendly way to other people that could be interested in your final results. In this case, dispatch. And in general, to give you an idea how you can use LLMs with your learning of doing reverse engineering for video games. Yeah, I think that's it. Thank you. Bye-bye.